Hello all, today we are going to solve some of the problems related to mathematical induction. So our question is 1 plus 4 plus 7 and so on up to n terms is equals to n times 3n minus 1 by 2. So we are first going to solve this question. So to start with mathematical induction, we first let our statement as Pn. So Pn is 1 plus 4 plus 7 plus and so on n terms equals to n times 3n minus 1 divided by 2. So by the process of mathematical induction, first we show P1 is true. So for this replace n by 1. But I think we don't have the nth term, so before this we first find the nth term of the series. So the difference is, look at here, the difference is 3, so this is a arithmetic series. So on arithmetic series the first value is a is 1, and the difference, common difference, is second term minus first term, which is 3, and the nth term is denoted by Tn, so which is given by a plus n minus 1 d, and this is a means 1 plus n minus 1 d, d means 3, now which is 1 plus 3 1 is 3 minus 3, and which is 3n minus 2. So this is our what the general term or nth term. So nth term is this, now our statement changes to Pn as 1 plus 4 plus 7 plus 1 up to nth term is 3n minus 2, and it is n times 3n minus 1 divided by 2. So by mathematical induction method, first we try to show P1 is true. So for this replace n by 1. So our LHS is 3 times n minus 2, so that 3 times n means 1 minus 2, it is 1. Now again taking RHS, so in RHS also replace n by 1, so 1 times 3 times 1 minus 1 divided by 2, and 1 times, this is 3 1 is 3 minus 1 is 2 divided by 2, which is also 1. So we got both RHS and LHS are same, that is 1. So we can say that P1 is true. P1 is true. Now our next step is to suppose hypothesis. Suppose Pk is true. That is, Pk is true means we have to replace n by k. So it is 1 plus 4 plus 7 plus and so on up to 3k minus 2 equals to, it is k times 3k minus 1 divided by 2. So this is our supposition. We can use this to prove this. To prove, we have to prove pk plus 1 is true. So what is our process? We first show P1 is true, and we suppose Pk is true, and we show Pk plus 1 is true. That is, so what we have to prove is 1 plus 4 plus 7 plus and so on Now replace this k by k plus 1. So 3 times k means k plus 1 minus 2 equals to, here also replace k by k plus 1. K plus 1 times 3k plus 1 minus 1 divided by 2. So this expression we have to prove. Now to prove this, take LHS and then we obtain RHS. 1 plus 4 plus 7 plus and so on up to 3 times k plus 1 minus 2. Now this is our k plus 1th term. So 1 plus 4 plus 1 plus 4 plus 7 plus and so on. So what is our kth term? Right, kth term also. This is k plus 1th term. So kth term is just the term just before this is 3k minus 2. 3k minus 2 and plus write this as well, 3k plus 1 minus 2. Now we are going to simplify this expression. What we know that we have supposed in inductive hypothesis that the term, the expression of here 1 plus 4 plus 7 plus 3k minus 2. So this is in our what supposition hypothesis, 1 plus 4 plus 7 plus and so on 3k minus 2, we can write k times 3k minus 1 by 2. So in place of this expression we can write k times 3k minus 1 divided by 2, and this is plus 3 times k plus 1 minus 2. Now take LCM as 2 and multiply this. This is 3k square minus k times 1 is k, plus we have to multiply this 3 to the 6 times k plus 1 and 2 to the 4, so minus 4 is here. Now continue simplifying this. Now so on simplifying this we get we do here so this is just let me copy this. So this is 3k square minus k plus just open the bracket, and this is 6k plus 6 1 is 6 minus 4 divided by 2. Okay, now continue simplifying this. 3k square and this is minus k plus 6k is 5k plus this is 6 minus 4 is 2 divided by 2. Now this is we can factorize this, 3k square plus and k times 3 plus 2 divided by 2. Now this is 3k square plus 3k plus 2k plus 2 divided by 2. Now this is take common from here, so it is 3k k plus 1, again from here common is 2, so k plus 1 divided by 2. Now it is k plus 1 again common, so k plus 1 is common, so we have 3k plus 2, 3k plus 2 divided by 2. This is from LHS. Now again we have RHS. It is let me show you. So this is RHS is, we have here, look at this expression. So this is k plus 1, RHS is k plus 1 times 3 times k plus 1 minus 1 divided by 2. So I have copied from here. So this is our RHS. Now from RHS also we are going to simplify the expression. So this is k plus 1. Now multiply this k plus 1 by 3, so it is 3k plus 3 minus 1 divided by 2, and this is what k plus 1, and this is 3k plus 3 minus 1 is 2 divided by 2. So we got exactly the same expression as LHS. So LHS and RHS are same, so we can write pk plus 1 therefore is true. Pk plus 1 is true. So by mathematical induction, so by principle of mathematical induction, so by principle of mathematical induction, our given statement Pn is true. Given statement Pn is true. So we can solve this question as this method. So we go to next question. We have next question. So our next question is this. Okay. 1 times 2, 2 times 3, 3 times 4 to n terms is this. So again we are missing our nth term from this series. So first of all we find the nth term of this series. So our series is 1 times 2, 2 times 3, 3 times 4 and so on up to n terms. So first of all we find the nth term of the series. So nth term of the series is Tn, and so we divide the series into parts. That means the series obtained from nth term of, first of all write the first term of the each term. Okay, this is 1 2 3, so we can write 1 comma 2 comma 3 and so on, and this is times nth term of. Now what are the numbers in the second? So in 2 3 4, so this is 2 comma 3 comma 4 and so on. So this is, now we have two series. First is 1 2 3 and so on. So we can directly write n as the nth term of this series, but by calculation also we can obtain. So this is 1 2 3 and so on, and the difference is 1. So this is arithmetic series, so a plus n minus 1 d. So this is a means 1 plus n minus 1, the difference is also 1, so it is 1 plus n minus 1, minus 1 plus 1 cancel, so that first term so that the series first sequence has the nth term as n times. Now the second sequence is, we have second sequence is 2, 3, 4 and so on. So this is also difference 1, so it is also what arithmetic series. So we have this formula. So a means 2, n minus 1, difference is all again 1, so 2 plus n minus 1, so it is n, 2 minus 1 is 1, so that n plus 1 is the nth term of this series. So we can write n plus 1. So first sequence has nth term n, and second sequence has nth term n plus 1. So multiply this, n into n is n square plus n was the n. So this is the nth term of the given series. So first we suppose, let Pn, so our supposition is 1 into 2 plus 2 into 3 plus 3 into 4, same as question, plus and so on, plus our nth term is n square plus n, and this is equals to, from question we can write what is on the right side, and this is n times n plus 1 n plus 2 by 3, so that n times n plus 1 n plus 2 by 3. So now our first step is P1, so replace n by 1. So our LHS is n square plus n, so replace n by 1, what we get, n square plus 1 square plus 1, so this is 2. Now RHS is n times n plus 1 n plus 2, that is 1 1 plus 1 1 plus 2 divided by 3, so which is 1 times 1 plus 1 is 2 and 1 plus 2 is 3 by 3, so 3 and 3 cancel, 2 ones are 2, so our LHS and RHS are same. We can write P1 is true, therefore P1 is true because our LHS and RHS are same. Now we suppose PK is true. Suppose PK is true, that is PK is true means 1 into 2 plus 2 into 3 plus 3 into 4 plus and so on, k square plus k. I am writing from here, so replacing n by k, n square plus n means k square plus k equals to, on right hand side also replace n by k, that means k times k plus 1 k plus 2 divided by 3. So this is our inductive hypothesis, and number 3, what we have to show is, we have to show pk plus 1 is true. So for this we have to show 1 into 2 plus 2 into 3 plus 3 into 4 plus and so on. Now replace k by k plus 1 here, so this is k plus 1 whole square plus k equals to, on right hand side also replace k by k plus 1, so this is k plus 1 and k plus 1 plus 1, and this is k plus 1 plus 2 divided by 3, and this expression we have to prove. So taking LHS, we can start from LHS. So LHS equals to 1 into 2 plus 2 into 3 plus 3 into 4 plus and so on, k plus 1 whole square plus k. So this is our left hand side. Now again we can continue our calculation. So this is our LHS. Now 1 into 2 plus 2 into 3 plus 3 into 4 plus and so on, and this is our k plus 1 term. So before this term, here also k plus 1, okay, wait, k plus 1 square, because k square means k plus 1 square and k means k plus 1, so we can write here k plus 1 here. So here is also k plus 1, okay. So this is k plus 1th term. So before this term we have one term, that is kth term. So k square plus k term is this, and plus the last term is k plus 1. So k plus 1 whole square plus k plus 1. So now we are going to simplify this expression, but what we have supposed, look at here. So up to here, uh, up to here we have supposition that up to here we can write or replace the expression by this. So k plus 1 k plus 2 by 3. So for this expression we can write k plus 1 k plus 2 divided by 3, okay, plus our remaining term is k plus 1 whole square plus k plus 1. Okay, now I think on 3 terms, look at here, there is common k plus 1. So k plus 1 k plus 1 k plus 1, so we can take common from here, k plus 1 common, so remaining is k plus 2 divided by 3 plus, here is k plus 1 whole square, so k plus 1 remaining, and here is 1. So k plus 1 is common, so that we have only 1. Now k plus 1, now taking 3 as LCM, so k into k is k square plus 2 times k plus 3k, 3 ones are 3 plus 3 ones are 3. Now k plus 1 k square plus 2k plus 2k is 2k plus 3k is 5k plus 3 plus 3 is 6 divided by 3. Now we are going to what, factorize this, k square plus k times, and this is 3 plus 2 plus 6, 3 plus 2 is 5 and 3 to the 6, so that divided by 3. Now k plus 1, this is k square plus 3k plus 2k plus 6 and divided by 3. Now this is k plus 1. Now from here take common, this is k and k plus 3, plus from these two terms we can take common 2, and this is k plus 3 divided by 3. Now k plus 1 and k plus 3 is again common, k plus 3, and we have k plus 2 divided by 3. Now rearranging the term, so we write k plus 1 and k plus 2 in second and k plus 3 at last divided by 3. I think the RHS is same as this. Look at the RHS, look, see here. So our RHS is k plus 1 k plus 1 plus 1 k plus 1 plus 2 by 3. So we can, okay, no problem, take RHS, we have k plus 1 and k plus 1 plus 1, k plus 1 plus 2 divided by 3. This is our RHS. So this is k plus 1, k plus 1 plus 1 is 2, k plus 1 plus 2 is 3 divided by 3. So we got the same expression as LHS. So we can say that pk plus 1 is true. Therefore pk plus 1 is true. Therefore by principle of mathematical induction, given statement is true. Given statement Pn is true. So thank you so much guys for watching this video. I will be come back with new video. Till then, bye bye.